This is Physics Chapter 4, Problem 12. Two forces are applied to a car in an effort to move it as shown in figure 4.12. What is the resultant of these two forces? If the car has a mass of 3,000 kilograms, what acceleration does it have? Ignore friction. So you start with your drawing, which is basically the same drawing in the book. And I'm going to make this force 1 and this will be force 2. And then this is my positive x, and this is my positive y. And then I'm going to copy down the triangles to see clearly. This is 450n, this is my f1. So then, since you know that this angle and this is a right angle, you know that across it is the sine of 10 degrees times 450 newtons, and then you know right here's cosine 10 times 450, and then your second triangle, you know that this is 30 degrees and this is 400 newtons, so then you know sine of 30 times 400 gives you that side. And then I'm basically just going to solve for these ones. Oh, this is F2. So that I already have the numbers. So F1 in your y direction, which is this because your y direction's up and down. And that gives you 443.16 newtons. And then your F2 in your y direction's up and down. And that gives you 346.41 newtons. And then your F1, which is technically going left because you're going negative x. And then F2 is right because you're going positive x. So once you have these, you can find your resultant. So your forces all in the x direction is, your x direction's left and right. So since you're going left, that's technically a negative direction, and right is a positive direction. So you want to do 200 newtons minus 78.14. And that gives you 121.86. And then your y, they're both in the positive direction because the car's moving up no matter what. So you want to add the two. So once you have your x and your y, you basically want to find the hypotenuse. So you do that with a squared plus b squared equals c squared. So then your C is 789.92, newtons. And then you need to find the angle that it's going at because it's not going straight. There's two different angles. So you find that with tangent theta So then your theta comes out as 8.67 degrees. So your total resultant and then so part B, if the car has a mass of 3,000 kilograms, what acceleration does it have? That's the same, you use your formula, and I just moved around to find the acceleration. So your forces divided by your mass, which is given. So then, for part B, this is your acceleration.